looking for a family of curves. Now the idea of a family of curves is that you can have, for example, I'm just making up a family, let's say we had x squared. We know that x squared looks like this, goes through the origin. We call that y equals x squared, it's a bit pointy. A family of curves for this x squared or quadratic family could be defined by x squared plus c. What that does is it changes or translates the graph up or down. So for example, you might have y equals x squared plus 1. We know that would be here. Or you might have y squared, x squared minus 2. So that would be down here. So you've got this family of curves. They're all the same curve, but they're basically just translated up or down. And when you do integration, and you integrate a function, when you introduce this plus c, you're actually giving a solution which is a family of curves until you know the values of x and y that specify what c has to be. Then you have a particular solution. So when we're looking at general solutions, that's really just a family of curves. So the question here is asking us find the family of curves whose gradient is e to the 2x. So when you see gradient, we know that's dy dx. So the gradient is e to the 2x. The family of curves that have that gradient, family of curves, would be the curves where we've integrated this and found y equals a function of x. So what we can do is a very similar thing to the previous example. I'm just going to split the dx up to the other side. It's a separable differential equation. Integrate both sides. So y equals e to the 2x on 2 plus c. And this is our family of curves. A family of curves with the gradient e to the 2x. Now it says here for part B, and that's part A, I'll just label that. Part B says, can you find the equation of the curve whose gradient is e to the 2x, so we know that, and which passes through 0, 3. So this is what's called a general solution, what we found here. Remember, a general solution has the plus c. We're now going to find a particular solution. So it's a particular member of this family of equations. And it's the particular solution when, and I might actually write this in its form, x equals 0, y equals 3. So what we can do is simply write down our equation, but now in place of y we write 3, in place of x we're going to put a 0. So we've got 3 equals a half plus c. So that means that c equals 2.5 or 5 over 2. So therefore the equation is this guy, y equals e to the 2x over 2 plus the c that we found. And it's a particular c that we found given the point that our equation had to actually pass through, or our curve had to pass through. So our particular solution in this case for this point is y equals e to the 2x on 2 plus 5 on 2.